Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture Lecture Series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you. Thank you very much. I'm Philip Emeagwali. The world's fastest computer that's powered by up to 1 billion processors was an invention that followed my discovery of parallel processing. The knowledge of how to solve the so-called grand challenge of supercomputing and do so across up to 1 billion processors pre-existed, but it was unknown until I discovered that parallel processing can simultaneously yield the highest speedups across an internet. On July 4, 1989, I discovered that fastest speed across a virtual supercomputer, that's a global network of 65,536 coupled processors that shared nothing, and that's an internet in reality. The world's fastest computer is the vital technology that posterity must harness and use to move humanity forward. I came of age in the 1970s and 80s. In those 2 decades, the terra incognita that was the emerging field of fastest computing across 1 million processors was as empty as a ghost town that had only one permanent resident. I was that permanent resident at the farthest frontier of fastest computing. My new internet was a small copy of a never before understood internet that's outlined and defined by its 65,536 processors that encircled a globe instead of billions of computers around a globe. I visualized each of my 2 to the power 16 off-the-shelf processors as equal distances apart and around a globe in a 16-dimensional hyperspace. And I visualized my ensemble of processors as evenly distributed across the hyperspace of a hypersphere, across the hypersurface of a hypersphere in a 16-dimensional hyperspace. I visualize my ensemble of processors as outlining a new internet, which I visualized in my 16-dimensional hyperspace. What is Philip Emeagwali known for? I discovered how to combine computers into a supercomputer that's an internet. That discovery is like a light from an ancient sky. I'm the only father of the internet that invented an internet. In the early 1980s, I was discouraged from doing what white scientists were allowed to do. I was discouraged from programming a $40 million vector supercomputer that was in Camp Springs, Maryland. I was discouraged from using another vector supercomputer that was in San Diego, California. I was discouraged from using supercomputers also bought with black tax dollars. Because I wasn't allowed to program vector supercomputers, I was forced to program only massively parallel supercomputers, which in the 1970s and 80s were the most undesirable to program to solve the most difficult problems in mathematics. A school essay question is this: how did Philip Emeagwali change the way we look at the fastest computers in the world? In the early 1980s, my unproven idea of the fastest computing across the slowest processors was mocked and ridiculed as a beautiful theory that lacks an experimental confirmation. In the 1970s and 80s, fastest computing across a new internet, that's a new global network of 64 binary thousand processors, was still in the realm of science fiction. But on the 4th of July, 1989, the day I discovered the fastest speed in computing, it didn't matter that I had no research budget or that I was black and sub-Saharan African. What mattered was that the new way of fastest computing fundamentally changed the way we look at the modern computer and changed the way we solve the toughest problems in mathematics arising in computational physics or arise in large-scale computational algebra and arise as the complicated partial differential equation that governs initial boundary value problems at the frontiers of calculus, algebra, and physics that define the most important applications of the supercomputer. That's a $45 billion a year industry. My quest was to use my new internet as my test bed for solving the toughest problems that arise in mathematics, science, engineering, and medicine. My fastest computing theory was that the one and only one technique for solving the most difficult problems in mathematics in supercomputing that span across algebra, calculus, and physics was to reformulate each problem. For that reason, I chopped up the most compute-intensive problems into an equivalent set of 1 billion initial boundary value problems that can then be solved across 1 billion processors and solved with a one problem to one processor correspondence. To be exact, I must experimentally confirm my world's fastest computing theory as true and across processors. At 8:15 in the morning on July 4, 1989, I confirmed my fastest computing theory. I did so by executing the world's fastest computation and by using my ensemble of 65,536 processors to solve my 65,536 initial boundary value problems that defined the whole grand challenge problem, including global climate modeling for climate changes. My contribution to physics is this: I effectively removed the adjective grand from the phrase grand challenge problems of physics. In 1982, I gave a lecture on the world's fastest computing. That lecture was mocked as science fiction. I was ridiculed because my theorized speed increase of a factor of 65,536 across as many processors was then believed to be impossible to attain. 15 years earlier, between April 18 to 20, 1967, a revered supercomputer expert named Jim Amdahl, quote-unquote, discovered Amdahl's law. In essence, Amdahl's law decreed that supercomputing across the world's slowest processors will forever remain in the realm of science fiction. During the following 22 years, Amdahl's law convinced supercomputer manufacturers to continue to use only 1, 2, or 4 custom-made processors to power their machineries. My theory was that thousands or millions or even billions of processors should be used to power the world's fastest computers. On July 4, 1989, I discovered that fastest computing across slowest processors is not science fiction. In 1989, it was an epiphany for me to discover that in my supercomputing across my global network of processors, that my speed increase of a factor of 64 binary thousand-fold would have been impossible if I didn't communicate across my new global network of email wires. Emails married my processors together. Emails outlined and defined my new internet that enshrouded a globe. As a mathematician who came of age in the 1970s and 80s, the lesson I learned was this: the ordinary genius insists on programming only the processors within the network of his email wires and processors. The magical genius discovers she must command and control all her 2 raised to power 16 or 65,536 processors. She must control them via their 16 times 2 raised to power 16 or 1,048,576 email wires. The high-performance, massively parallel supercomputer genius who embarked on a quest for the world's fastest computer of the 1980s must look along 16 mutually perpendicular directions in hyperspace. That supercomputer genius must understand how to program across billions of processors that uniformly outline a globe that's a metaphor for the Earth. In the 1970s and 80s, I visualized myself as a person who discovered the world's fastest computer in hyperspace. I visualized myself as a programmer of the supercomputer, or rather as a conductor of an ensemble of billions of processors. That ensemble of processors wasn't a computer by or in itself. That global network of processors was a new internet in reality. In 1989, I was in the news because I was the first supercomputer conductor to orchestrate the humongous email communications. Among my 65,536 processors, I executed them automatically. I sent and received emails across what was, topologically speaking, the surface of a globe that had 2 raised to power 16 or 65,536 processors uniformly distributed across that globe. That invention was a new internet that I visualized as a small copy of the internet. I'm the only father of the internet that invented an internet. An African-born scientist conducting research at the farthest frontiers of knowledge of mathematics, physics, and computer science, and doing so in the USA, needs an enlightened American female research scientist who is also of African descent and needs her to succeed. that African-born research scientist needs an American-born research scientist as his anchor and grounding force. I met my wife, Dale, on the second Tuesday of June 1978 in Baltimore, Maryland. Dale was born in Baltimore and as an American of African descent. We were both research scientists in Washington, D.C. In the 1980s, my wife Dale was an award-winning scientist. As a research scientist, Dale was then better known than I was, and she was my role model. A question in high school essays is this: what is the contribution of Philip Emeagwali to physics? My contribution to physics is this: I extended the borders of knowledge of modern physics to include large-scale computational physics that's executed across millions of processors. In 1989, I was in the news because I discovered how to solve the most difficult problem in a branch of physics that's called extreme-scale computational fluid dynamics. Such compute-intensive problems include the fastest computing and the large-scale modeling of the flow patterns of water and air that occur during hurricanes and tornadoes. The accurate predictions of the occurrences of hurricanes and tornadoes help protect lives and properties. I discovered how to execute the fastest computing of aerodynamic flows that must be used to design hypersonic aircraft. I discovered how to compute in tandem large-scale codes in computational fluid dynamics. The fastest computational fluid dynamics codes must be used to design the most efficient shape that reduces the drag on a submarine and an automobile. I solved that initial boundary value problem that's governed by partial differential equations at the frontiers of calculus and computational fluid dynamics, and I solved it by drawing on both my physical and geometric intuitions, both as a physicist and a geometer, and drawing on my mathematical analogies between meteorology and geology, and creating metaphors between the globe in its 3rd and 16th dimensions. In the late afternoons, from the late 1970s through the 80s and 90s, I decompressed by jogging across the Rock Creek Trail of Silver Spring, Maryland, or playing tennis in Corvallis, Oregon, or at the 2 tennis courts that were next to the Penumbra Theater of St. Paul, Minnesota. In the early 1990s, I stayed physically fit by jogging up to 50 miles a week. I trained for 26-mile marathon races and did so around the 70.5-acre Lake Como that was my backyard of the Burlington of Energy Park of St. Paul, Minnesota. What's a decade in the life of a physicist? As a research physicist, my specialty was fluid dynamics, particularly large-scale computational hydrodynamics. Back from September 1, 1981 through August 1986, I lived a 15-minute stroll from the Graymax Heliport building in Silver Spring, Maryland. The Graymax building was an approved landing pad for helicopters. The Graymax building was the then headquarters of the U.S. National Weather Service. During those 5 years, and from Mondays through Fridays, I stopped each morning and spent 5 hours with hydrologists and meteorologists. I did so on my way to the nearby metro station of Silver Spring, Maryland. From Silver Spring, from metro station, and after lunch, I rode a small shuttle bus to College Park, Maryland, where I spent the rest of my day in research seminars given by visiting mathematicians, physicists, and computer scientists. At about 6 o'clock in the evening, I played tennis at one of the 14 lighted tennis courts at the nearby Fieldhouse Drive of College Park, Maryland. During my 5 years, from 1981 to 1986, with research meteorologists, I was inspired to investigate the finite difference discretizations of the primitive equations of meteorology that were used by the U.S. National Weather Service and used to forecast the weather. Earlier and before my arrival at the U.S. National Weather Service, and in the 3 years that were inclusive from 1978 through 1981, I researched in the fluid dynamics of both free surface water flows and subsurface flows of crude oil, injected water, and natural gas that were flowing through porous media. A typical porous medium is an oil-producing field that can be up to 7.7 miles or 12.4 kilometers deep. In those 3 years, I lived in the bustling Adams Morgan neighborhood and in the Meridian Hill Hall that was next to the Malcolm X Park and along the 16th Street of Washington, D.C., or Washington, District of Columbia. During the 10 years that followed June 5, 1977, I moved around and between Washington, District of Columbia, Baltimore, Maryland, Silver Spring, Maryland, College Park, Maryland, Casper, Wyoming, and Laramie, Wyoming. In those 10 years and those cities, I attended about 500 advanced scientific lectures. It was a rare achievement for a supercomputer scientist to attend that many lectures, that many seminars. Each seminar was at the frontiers of knowledge in mathematics, physics, and computer science. Attending those 500 scientific lectures enabled me to have far more knowledge and command of materials than any supercomputer scientist on YouTube, and to become the multidisciplinary mathematician who posted 1,000 multidisciplinary videos on the Emeagwali YouTube channel. That was the reason I was described as an autodidact and the person who invented the world's fastest computing across up to 1 billion processors. In the 1970s and 80s, it was impossible to solve the most difficult problems in mathematics and physics, such as forecasting the weather, and solve them across 1 million processors. For that reason, I had to invent, not learn, how to solve the world's biggest problems by executing the first world's fastest computing across the world's slowest processors that shared nothing with each other. Like other inventors, I invented fastest computing without the benefit of a supercomputer instructor. That is, I was the first person to understand how to harness the world's fastest computing as we know the technique today. In the 1980s, I attended 500 lectures on the latest scientific discoveries. Each lecture was delivered by the discoverer or inventor, who was a leading mathematician or physicist or computer scientist. After 10 years of daily conversations with the foremost thinkers at the frontiers of knowledge, I became a multidisciplinary mathematician who can discover new physics and invent a new computer that's fastest. That was how I became known. For my contributions to the development of the world's fastest computer, I discovered the world's fastest computer across the slowest processors in the world. I discovered the world's fastest computer on the 4th of July 1989 in Los Alamos, New Mexico, USA, and across an ensemble of 65,536 processors. A question in school essays is this: what is the Philip Emeagwali internet? I visualize my new internet as a new global network of 64 binary thousand or 65,536 off-the-shelf processors. That internet was married together as one seamless, coherent, and gigantic supercomputer, and married by 1 binary million email wires, or 1,048,576 wires that were uniformly distributed around a globe. But I visualize my globe to be shaped as what mathematicians call a hypersphere in the 16th dimensional hyperspace. My discovery of a new internet, that's a new global network of processors, and that's a new supercomputer, was a moment of revelation and insight. I discovered how to harness the trillions of processors and the billions of computers that could outline and define the internet of the future. I discovered how the planetary supercomputer of forthcoming centuries could look like a planet-sized supercomputer that harnesses all the processors and computers on Earth and uses them to solve a difficult problem in mathematics and physics, must by necessity require that all emails be at once sent and synchronously received across the Earth. The processing nodes of that planet-sized supercomputer must be uniformly distributed across the Earth. That scientific discovery was my eureka moment of revelation. It helped me to understand that harnessing a billion processors is the key to making the supercomputer fastest. That scientific discovery was how I gained insight into the essential meaning of a global network of off-the-shelf processors that were coupled and identical to each other. It was a global network of identical email wires that I visualized as tightly circumscribing a hyperglobe in hyperspace. That new technology was a new internet that was comprised of 65,536 processors. In 1989, I was in the news because I discovered that those 64 binary thousand processors can be used to emulate one seamless, coherent, and gigantic processor that was at the processing core of the world's fastest computer. That new computer and new internet are like two sides of the same coin that are different but yet congruent and necessary. The head side of the coin contains the ensemble of processors. The tail side of the coin contains the ensemble of email wires. The head and tail sides are married to each other to form the new internet called the Philip Emeagwali internet. I'm the only father of the internet that invented an internet. A new supercomputer was born at 8:15 in the morning of July 4, 1989 in Los Alamos, New Mexico, USA. That new supercomputer use the slowest processors in the world to execute the fastest processing in the world. That new supercomputer fundamentally changed the way we look at the computer. The world's fastest computer consumes enough power to run 10,000 homes. A supercomputer communicates across up to 200 miles of cables. The world's fastest computer occupies 8,000 square feet of floor space and comprises of hundreds of racks, millions of processors, endless wires, and blinking lights. That new supercomputer is not a computer by or in itself. That new supercomputer is a new internet in reality. In a dream, my new internet appeared to me like a deity. That supreme power enshrouds the earth as an electronic cloth. I imagined that deity to be the global planet-sized superbrain for our descendants of forthcoming millennia. That superbrain could be a billion trillion coupled super intelligent processors. My epiphany was the eureka moment when I comprehended that the internet of a million could evolve to become the core of the Earth-sized supercomputer of our post-human gods. For the past century, weather forecasting, the precursor to climate modeling, was the poster boy of the list of the two most difficult problems in mathematics and physics. Fastest computing across a globe was speculated and entered into the realm of science fiction, and did so when it was first published on February 1, 1922. Fast forward 67 years, I was in the news because breaking that supercomputer speed-up barrier was computing's equivalence of being the first person to summit the peak of Mount Everest or climb to the top of the world. The science fiction of today could become the non-fiction of tomorrow. On February 1, 1922, a science fiction human supercomputer was described as 64,000 humans calculating together to forecast the weather for the entire Earth. I stumbled onto that science fiction story while I was working as a university librarian in Monmouth, Oregon, USA, in the summer of 1974. I reformulated that idea of 1922 as the first world's fastest computing across an internet. I visualized my new internet as a new global network of 64,000 computers. Back in 1974, my internet was mocked as a blue sky thinking. In that decade, fastest computing across up to 1 billion processors remained in the realm of science fiction. 67 years later, on the 4th of July, 1989, that science fiction manifested as a non-fiction across a new internet. I visualize the Philip Emeagwali internet as a new global network of 64 binary thousand processors around a globe. I visualize that globe as a hypersphere in a 16-dimensional hyperspace. My visualization differed from the 64,000 human computers around the globe in 3-dimensional space. After the 4th of July, 1989, fastest computing across up to 1 billion processors, or using 1 million processors to solve the same problem and do so at once, left my experimental supercomputing laboratory. My invention or new knowledge entered every supercomputer that has been manufactured since my scientific discovery of 1989. A question in school essays on famous physicists and their discoveries is this: what did Philip Emeagwali contribute to physics? My discoveries and contributions to physics are these: the slowest processors in the world can be used to manufacture the fastest computers in the world that can be used to solve the most difficult problems in physics. In 1989, I was in the news because I discovered that up to 1 billion self-contained processors could be utilized to forecast tomorrow's weather and deeply understand next century's climate change. I invented the Philip Emeagwali Internet, but it was renamed and credited to a white inventor. I solved the most difficult problem in computational mathematics, and I solved it alone. That grand challenge problem, namely the world's fastest computing across the world's slowest processors, solving the world's most compute-intensive problems, was indirectly and first posed 7 decades earlier. I was the first person to sketch a new internet. The idea that suddenly the internet was invented in the 1970s just doesn't ring true. That said, I was the first person to sketch a new internet. My new internet was a global network of processors that emulated one seamless, coherent, and gigantic supercomputer. My invention made the news headlines because it materialized as the world's fastest computer. For these 15 years following 1974, my not so fully formed hypothesis that was published on February 1, 1922, continuously grew in my mind. It became my fully formed theory that I constructively reduced to practice. It physically materialized as my new global network of the 64 binary thousand slowest processors in the world that seamlessly computed as one coherent supercomputer that became the world's fastest computer. In 1989, I was in the news because I discovered a fundamental change in computational physics. Someone asked, what's the most fundamental change that occurred in computational physics? A century ago, the physics model of the spread of the coronavirus disease could only have been formulated on the blackboard. Half a century ago, the spread of COVID-19 could be modeled on a computer, but that was powered by only one processor. Today, a supercomputer that's powered by up to 10 million processors can be used to model the spread of COVID-19 across a Nigerian bus that packs passengers like sardines. That sea change from modeling on a blackboard to a motherboard is the world's motherboard to the world's fastest computer is the most fundamental change in computational physics. It was a quantum shift from the February 1, 1922 science fiction and paradigm of 64,000 human computers that were quote-unquote racing the weather for the globe. My 1974 theory of the world's fastest computer was about as many processors or computers working together to solve the most difficult problems in mathematics and physics and solve them across my ensemble of processors that were evenly distributed around a globe. My discovery of the first supercomputing across the world's slowest computers occurred at 15 minutes after 8 o'clock in the morning of July 4, 1989 in Los Alamos, New Mexico, USA. In 1989, I was in the news because I discovered that 2 raised to power 16 or 65,536 processors, or as many electronic computers that were uniformly distributed around the hypersurface of a globe in a 16-dimensional hyperspace, can be deployed to uniformly compute more accurate climate models around a globe. That is, I discovered that a multitude of ordinary processors could be used to foresee otherwise unforeseeable long-term global warming. In Google searching for quote-unquote father of the internet, the first name that's suggested is Philip Emeagwali. My signature discovery that made the news headlines in 1989 was my experimental confirmation of my 1974 paradigm of the world's fastest computing executed around a new internet. That's a new global network of 65,536 or 2 raised to power 16 off-the-shelf processors. I visualized my processors as uniformly distributed around a 16-dimensional globe that's embedded inside a 16-dimensional hyperspace. In the decade and a half that followed June 20, 1974, on a supercomputer that was at 1800 Southwest Campus Way, Corvallis, Oregon, USA, I visualized my globe in the 16th extraordinary dimension rather than in the 3rd ordinary dimension. We need to change the way we look at the internet. In my new paradigm of the world's fastest computing executed around a new internet that uniformly encircles a globe in the 16th dimension, I visualize my 65,536 processors as 2 raised to power 16 processors, in which each processor was directly connected to its 16 nearest neighboring processors. Those processors shared nothing, and each operated its operating system. As the first mathematician to program an ensemble of 65,536 processors and use them to solve one of the most difficult problems in mathematics and physics, my grand challenge was to figure out how to marry millions or billions of ordinary processors together and marry them as one seamless, coherent, and gigantic supercomputer, and marry them together by their 16 times 2 raised to power 16, or 1,048,576, or 1 binary million email wires. I used emails to send and receive intermediate answers to my testbed physics-inspired problem. My testbed problem was an initial boundary value problem of mathematical and computational physics that was governed by a system of partial differential equations beyond the frontier of calculus and fluid dynamics. I'm the first supercomputer scientist as it's known today. As the first pilot to quote-unquote fly the world's fastest computer that was powered by 64 binary thousand processors, I asked the traffic guys to show me lights from the ground. Realizing that I was black and African, they turned off all the lights. Fortunately, I was an instrument-rated pilot who could land airplanes blindfolded. In the 1980s, I programmed a new global network of 65,536 coupled processors which powered a new supercomputer that I defined as a new internet. I programmed my processors blindfolded. In the 1980s, I was the remote programmer of 16 of the most massively parallel supercomputers in the world. I was logged into supercomputers 24/7. For parallel programming, I was known as the go-to person within the supercomputing community that include from the supercomputer centers in San Francisco, California, to Oak Ridge, Tennessee, to Chicago, Illinois, to Cambridge, Massachusetts, to Washington, District of Columbia. However, supercomputer scientists in those centers who knew me by name only assumed that Philip Emeagwali was a white supercomputer scientist with an Eastern European last name. My contribution of parallel processing changed the way we look at supercomputers. For me, the emerging paradigm of fastest computing across a new internet that is described as the Philip Emeagwali internet. I visualize my new internet as a new global network of processors. In my mathematical theory, my globe was embedded within my 16-dimensional hyperspace, but in my world's fastest computing, my globe in hyperspace was quote-unquote etched onto the 3-dimensional space. I was in the news for experimentally discovering how to compute and communicate across my new internet. My internet surrounded a metaphorical globe in the 16th dimension and did so just as the internet circumscribes the earth in the 3rd dimension. I was in the news because I theoretically and experimentally discovered how to make fastest computing across slowest processors useful and harness it to solve everyday problems such as your evening weather forecast or foreseeing the spread of COVID-19. My discovery of the world's fastest computing remained my signature contribution to mathematics, physics, and computer science. Thank you very much. I'm Philip Emeagwali. Thank you. Thank you.
Insightful and brilliant lecture.